let us have another application of curve fitting. The U.S. Census lists the population of the United States as 249 million in 1990, 281 million in 2000, and 309 million in 2010. Fit a polynomial model passing through these points and use it to predict the population in 2020 and 2030. So, pause the video and try to find the model and use that model to predict the population in 2020 and 2030. Alright, now the first thing that we need to determine would be our points, because that would be our basis for our polynomial model. Now we know for a fact that the listing of the population are as follows: 249 million in 1990, 281 million in 2000, and 309 million in 2010. We can use these as our points. One thing here is that since they are not in table, it's kind of hard to determine whether this variable is the x or the y, because remember, our data point should be in the value x comma y. Now, we have here the actual population count and the year. And we know that if we're talking about xy variables, usually the one placed as the x would be the independent one, the independent variable, while the one placed in y would be our dependent variable. So based from here, our independent variable, which is the one that will just go unbothered, would be the year, while the dependent variable would be our population. So with that, we can have those as our variables. So we can let the year be x and y be the population in millions. So we don't need to write a lot of zeros. We'll just consider y and think of it in terms of millions. So our first point would be 1990 and then 249. Again, we'll just consider the millions later on after we have finished our model. So it will be an easier computation. Then our next point will be 2,281. And finally, here 2010, 309. So based from these values, we are now going to create our polynomial model. Based from our number of points, we have 3 points. Therefore, we're going to create a quadratic model. Given its general form of y is equal to ax squared plus bx plus c, let us now construct our model. So the first equation will have 249 will be equal to a times 1990 squared plus b times 1990 plus c. For the second equation, we have 281 is equal to a times 2000 squared plus b times 2000 plus c. For the third equation, I'll have 309 is equal to a times 2010 squared plus b times 2010 plus c. Now, the values here are quite big, and of course, this would be ideal if this is done with a software or a program that can solve matrices or systems of equations in general. In this case, if we're going now to present this as an augmented matrix, I will not expand these squared values as they are pretty big. So, in augmented matrix form, I'm going to have the following. For the first row, 1990 squared, 1990, 1, 249. Second row, 2000 squared, 2000, 1, 281. Then, for the last row, 2010 squared, 2010, 1, 309. And this is the augmented matrix that you can solve either by using Gaussian elimination or Gauss-Jordan elimination to find the values of A, B, and C. And again, we are not going to show the process of the Gaussian and the Gauss-Jordan elimination here. I'm going to use though Gauss-Jordan elimination, and hence I'm going to show already the reduced row echelon form. The process of the Gaussian or Gauss-Jordan elimination will be left to the viewer. So, the reduced row echelon form of our augmented matrix will be as follows. We're going to have for the first row 1, 0, 0, then rounded off to three significant figures, 1.14 times 10 raised to negative 5. Second, oops, that's quite long. Let's just fix that first. Okay. There you go. Second row of our reduced row echelon form of the augmented matrix, 0, 1, 0, then 2.75, rounded off to two decimal places. Third row is 0, 0, 1, negative 5,200. Sorry, that should be 200. 5,273.04. Hence, the polynomial model that we should be using would be y is equal to 1.14 times 10 raised to negative 5x squared. I'll write it down below here. No, wait a moment. Let's adjust our board. There you go. Plus 2.75x minus 5,273.04. This is the quadratic model that fits in our data points of 1990, 2000, and 2010. So if we're going to use this model to predict the population of 2020, therefore, there you go, we shall insert 2020 in our value, in our x rather. So we'll have 1.14 times 10 raised to negative 5 times 2020 squared plus 2.75 times 2020 minus 5,273.04. This is going to give us 328.48, and take note that when it's population, we should be talking in millions, so 328.48 million. The accuracy of the model will be left to the viewer to check on actual statistical values of the US Census. Now, doing also for 2030, we're going to use a different color. So, for 2030, we'll just use the same model. 1.14 times 10 raised to negative 5 multiplied by 2030 squared plus 2.75 times 2030 minus 5,273.04 will give us a value of 356.44 million. So these are the predicted values if we're going to use the model that we built to figure out the population of the US in 2020 and 2030, an application of polynomial curve fitting.